Okay guys, so we are back together, and in our last session we talked about central angles. So just a quick reminder, a central angle is simply an angle whose vertex is at the center of the circle. So here we have a central angle, and all that means is that the vertex is at the center of the circle. We can see that the angle cuts off an arc, and there's always a relationship between an angle and its arc. With a central angle, we can say that the angle is equal to the arc in measurement, and we're measuring everything in degrees. Well, today we're going to talk about these things called inscribed angles, which are obviously different, but that doesn't mean that they're much more challenging. So a central inscribed angle simply has its vertex on the circle. Now, technically, an inscribed angle is an angle whose vertex is on the circle and whose sides are made up of chords. So here we have an angle BCD, which is an inscribed angle. Its arc, we can call it its intercepted arc, is arc DB. What I want you to focus on is always know where the vertex of the angle is. Inscribed angle, it is on the circle. That's really important. And for inscribed angles, or in fact for any angle whose vertex is on the circle, this happens to be called an inscribed angle. We have a formula. And our formula right here, angle is half the arc. So it's not something super challenging as a formula. We can look at this quick, simple example here. If we have our angle is equal to half its arc, so its intercepted arc. So in this example, if we were told that the angle measures 40 degrees, then its arc is 80 degrees. And vice versa, we just plug in the one we know, the arc or the angle. If we don't have the correct angle and arc pair, then that just means there's more than one step. So let's look at a couple simple practice problems here. So for example, in our first problem here, we're looking for angle A. Well, let's find it. There's our angle, and there's our intercepted arc. So we always want to pair the angle with the arc. And now, of course, we have our simple little formula. Angle equals half arc. And we're going to plug in the one we know. In this case, we know the arc. So angle equals half. And in this case, our arc is 158. And when we divide that out, we're going to get 79. So our angle in this case is 79 degrees. And we're going to do the same thing with numbers 2 and 3. So I want you to try it. We're going to hit pause, try it, and come right back. Okay, so hit pause. Okay, we are back. So you've had a chance to try numbers 2 and 3. And let's see what we came up with. We're looking for angle A. We're going to use its intercepted arc, and angle A equals 12 degrees. In number 3, we're looking for angle B. So again, we're going to find it. We're going to find its intercepted arc. Now, in this question, the intercepted arc is 180 degrees. So, of course, we're going to take 180. We're going to divide that by 2 to get the angle. And we get 90 degrees. So whenever we have an angle that cuts off or intercepts a semicircle, it goes to the ends of the diameter, it's going to be a right angle. All right, awesome. Let's take a look at the next few. We're going to flip this around. Now we're given the angle and we want to find the arc. So again, our first step in the process is always going to be find the angle and the arc. Or in this case, we find the arc and then trace it back. So watch what happened here. We're going to find the arc that we're talking about, and then I'm going to take the ends of the arc and trace them back to that angle. And at that point, it's really the same question. These are the angle and arc that pair together. The angle is half of the arc. So 40 is half of arc BC. Make sure you put the little arc symbol above it, otherwise it's a segment, which is very different. A segment would be a straight line connecting B to C. We want the curve. So we're going to do some algebra here, and we're going to get 80 degrees. Okay. All right. Do 5 and 6. So hit pause. Okay, we're back. So again, our goal is to find arc BC. We're going to trace the ends of the arc back to its angle. And since the angle equals half the arc, in this question, we're going to get our arc is equal to, sorry about that, 152 degrees. Looking at our last one, we have our arc BC. We trace it back to find the angle, and we know that that angle measures 90. That angle measures 90. So our arc here is 180 degrees. Okay. All right, so let's try a few that are all mixed into the same problem. And we're just going to go one at a time and figure out what we can. So we're looking for angle PNO. So I want to find it first. PNO, there's my angle, and it is paired with the arc of 68. So angle equals 1/2 of 68, which gives us 34 degrees. So we'll erase that and we'll go to the next one. Arc PQ. So we're looking for arc PQ. Well, there's more than one way to do this, but one thing I noticed right away, look at our diameter. Our diameter cuts the circle in half. So this entire half of a circle is 180. That half of the circle is made up of 118 and the arc that we're looking at. So we have 118 plus PQ equals 180. And that's going to let us find the measurement of arc PQ by doing a little subtraction. And we get 62. Let's go to another one. Angle NMO. N, M, and then out to O. Well, it wasn't there. We had to draw it in. So angle NMO. Well, again, we can look at this like the question before it. We have a diameter. We have our diameter, which cut our circle into 180. We know this one is 68, which means that angle is 68. So if we find this arc, we will know that angle because the central angle is equal to the arc. In fact, if you look in the middle of the circle, don't we just have a y? So we have a linear pair. Those two angles are supplementary. So again, we have something like x plus 68 equals 180. And we can find that angle. I'm just going to write it on the left because there's not that much room. Our angle measures 112. So we can figure out angles, we can figure out arcs. We have some options in our approach. And let's take a look at our last one here. Angle QMP. So if, again, we have QM, we have to draw that if it wasn't in there already, P. So we're looking for this angle, which is the same as this arc. So arc QP or arc PQ. So really, it's the same. We've already done it. Our answer is 62. We don't have to do any more work in this question. So we have a couple central angle questions in there also. Couple arc addition, couple inscribed angle, couple central angle. We just mix it up a little bit. So let's look at these. A little bit more challenging because of the picture, but we're really not doing anything different. So let's see what's happening here. So let's see. We're looking for, in number 29, I'm going to blow it up a little bit more. In number 29, we're looking for angle A and angle C. So we'll start with one of them. We'll start with angle A. So here's angle A. We're looking for the angle, and well, if we knew the arc, that would be really easy. But right now we don't know the arc. But look further into the picture. That same arc, I'm going to trace the sides of the ends of that arc back. And check it out. The purple angle is 40, which means that arc is 40 degrees. Well, that is the yellow arc. So now I'm going to trace it back to that yellow angle, and I'm going to get 40 degrees. So angle A equals 40 degrees. So two inscribed angles are using the same arc. So that arc is going to be the connection here. Angle produces arc, arc results from angle. We just have to find how they pair up. So let's look at it again, and we'll go for angle C this time. So angle C. Angle C. So I'm going to find angle C, and I'm just going to trace it. There's angle C, and there's its arc. We don't know the arc, so we can't figure out the angle. But I'm going to look a little further into the picture. The same arc, if I trace the ends of it back, I get angle D. And angle D we know. So the angle is 32. The arc is 64. Since the arc is 64, its angle is 32 degrees. So angle C equals 32 degrees. So try number 30. Hit pause now. Okay, we're back. So let's try number 30. Let's see what's going on. Angle A and its arc. Its arc also comes from angle D. So angle D produce the same arc. Notice how I'm tracing them in both colors. So 73 times 2 is 146. But I'm going to take that same arc, which is 146, and trace it back to the angle and get 73. So angle A is 73 degrees. And using the same exact process, the same exact steps, I'm going to get angle C in this question to be 31 degrees. Okay. Number 31. Same exact process, same steps, just that we have a little algebra going on. We're still looking for angle A, we're still looking for angle C, but in some cases we have some algebra. So I want you to try 31. Hit pause now. And we're back. So let's see what's going on in number 31. Let's do angle A. So there's angle A and its arc, which of course we don't know. And I'm going to pair that. I'm going to use the same arc, and I'm going to trace the sides back, and I get a 45-degree angle. So angle B is 45, which means the arc is 90. Since the arc is 90, we're going to take that arc measurement and we're going to trace it back. Step that to that angle, and angle A is 45 degrees. Okay. Let's erase it, and we're going to do the same thing with the next one. So now we're going for angle C. So we have angle C and its arc, and we're going to take the same arc, trace its corners back, or trace its endpoints back to the angle, and we have angle D. So what's going to happen? Both angles produce the same arc. So both inscribed angles produce the same arc. So those arcs, or those angles, are congruent to each other. So that's going to be our equation. And we have all the algebra for it. 2x plus 8 equals 3x minus 24. We can, of course, do a little work here. So we're going to find x. And now, since we were asked for angle C, we're going to plug that in. And we have 2 times 32 plus 8. So 64 plus 8, 72 degrees. Okay. All right, awesome work, guys. We're going to finish the notes tomorrow, so we're going to stop there, and you can do your assignment now.